You asked and we're answering. Whether you attended one of the PADS Professional Rigid Flex Design webinars events live or watched the recording on demand, some great questions were asked, so let's get the answers. Hi, I'm John McMillan, and welcome back to another edition of this special series of PCB Tech Talks, the After the Webinar podcast series. In this special podcast series, I'll be joined by webinar presenters, and we'll be answering and discussing the questions submitted by attendees. As always, be sure to subscribe to this podcast, let us know the topics you'd like to discuss, and if you'd like to be our guest right here on PCB Tech Talk. Today, I'm joined once again by the webinar demo presenter, Brent Klingforth. Hey, Brent. Welcome back to PCB Tech Talk, the After the Webinar series, following your Rigid Flex Design demo. How are you doing?
I'm doing great. The webinar was a great success. A lot of people registered. Seems like a lot of interest. So,
yeah, it was great. I think to date it even trumped our latest highest attendance record. So it was a definitely high topic of interest. Before we get started, I just wanted to throw some of these factoids out about Rigid Flex Design and a lot of the drivers behind it. It's becoming very commonplace in tons of different design areas, from automotive to avionics to brakes and cameras, cell phones, the medical industry. Of course, we all know GPS systems and IoT is a really big driver for increasing demand for Rigid Flex. And one of the key returns on using Rigid Flex, this doesn't even have to be part of the design need, is elimination of connectors and things like that. And statistics show that Rigid Flex actually reduces product assembly time by as much as 50%. Also, the global demand for flexible electronics is expected to reach over $24 billion by 2026, according to Zion Global Research Analyst. So I think we're going to see more and more of it in designs and more of a need for it. And I think that's one of the reasons why it was such a really good topic to talk about. So we have some questions. We have some questions that we answered during the session. We have some that we're going to answer now, and we're going to recap those for anyone who may not have attended the live Q&A from the webinar. Of course, you can go to the on-demand and view the webinar if you didn't, but the Q&A is not part of that. So we're going to repeat the Q&A questions here and the ones that we didn't get to during this session. How's that sound?
That sounds great.
Cool. Well, I'll let you jump right in with the first question.
All right. Well, let's see. The first one here we had was, can you have a different stack ups for each of the rigid or flex sections of the design? And yes, that is, you can do that. As the video showed, when you go back and watch it, you'll see that you can select any area of the stack up and choose the layers that are going to be part of that section. Another nice feature in PADS Professional is the ability to create a scheme. So if you're doing a design with a lot of rigid or flex areas, different areas in the design, you can create a scheme where you define what the layers are that are part of that stack up for that scheme and then assign them to individual flex areas. So it just makes it a lot easier. The other advantage of that is if you need to make an adjustment to a stack up, you don't have to go back and touch all these different shapes. Remember which ones are the same. You just go back to a scheme, adjust it, and then all of those flex regions adopt that new stack up. So it's kind of a nice automation feature.
That's great. I have a question here on does the Rigid Flex DRCs will do DRCs for flex design at the product? Does it do it at the product assembly level? I guess at the top assembly. And I think as folks saw in your presentation, the ability to define those bin parameters and edit the design in 3D and view the design in the context of the 3D enclosure was shown, and that was terrific. So yes, 3D Rigid Flex aware design rule checks are a critical aspect and feature of Rigid Flex Design in PADS Professional, and having that visualization and verification in 3D will help to ensure that you and your design team is taking full advantage of all the open real estate in all three dimensions at the product assembly level, of course, while at the same time identifying potential design issues. So that was a really good question.
Yeah, and to go along with that, the tool, Professional is aware of what can be placed into a bend area on top of that. So you can tell it to override those restrictions but by default, the tool will look for, vias, trace direction changes, trace width changes. Do I have any components in those bend areas? Are all objects that the tool will DRC against in the tool, and then you can override those if you need to make an exception. But they're things that intelligently are being looked at.
Well, so let me just add to that one question, about restrictions of what can be placed in bend areas. And I just, to piggyback on what you said, standard practices include things like not changing the width of traces within a region. You should route traces perpendicular to the bend direction because lack of symmetry will increase the chance of stress buildup. You should distribute the traces evenly and no vias within the flex bend region.
So another question that was asked here is, during the presentation, you mentioned the need for teardrops in component pads and vias. Why is this a requirement? So the reason why this is needed is, again, we're in a flexible environment. And if you have any joints where a trace or a corner creates a 90-degree corner, it can cause a 0.4 failure. So in order to help prevent that, you need to make sure you taper the traces into like a via or a pin of a component so that you don't end up with that 90-degree corner. So that's why that is so important when designing a flex. If you place components on that flex, do via transitions, is that you teardrop all of your traces.
Okay, so to kind of piggyback on that one too, so how do you determine the bend radius? And the formula for bend radius obviously can be actually found in IPC 2223 standard. And it's based on flex layer count, copper deformation, and core, etc. So, for example, things like the number of times that a circuit will be flexed is a critical question. So, a one-time crease, that's where the flex is bent and creased to the point of zero bend radius, then installed in the final assembly. That's classified as a one-time crease. But in Brent's drill example, he's showing like flex to install, which is also referred to as static, is where the flex is bent to a required shape and installed in the final assembly. So, for example, unless the drill that he was using in the example fails and the flex circuit needs to be replaced, it's not really subjected to any further significant bending. And then there's dynamic, and that's where bending can occur repeatedly throughout the product's lifespan. Imagine a flip phone or some of the new phones coming out that display is hinged and there's constant opening and closing. That would be dynamic. But again, the formula for bend radius, check out IPC 2223.
Yeah, and again, to add to your response there, John, is that Paths Professional can DRC that information as well. So there's actually a rule you can define based on the 4 different types of flex. So single, double-sided, multiple layer, and dynamic bending. So you can take the multipliers that are in the IPC specifications, put them in the tool, and then it will dynamically check for your bend radius is based on the stack up thickness for that area. So the tool is going to tell you when your bend radius is too small when you start working with the design, instead of having to guess at that or DRC it manually or during a design review.
Yeah, and another really key part of rigid flex design is working with and getting feedback from your fabricator on the stack up and the material, the keep out regions and pin requirements and stiffeners, etc. Stuff like that. It really helps to ensure that design can be, to your specifications, but also, properly fabricated with high reliability that you're going to want in your products.
Yeah, and as you mentioned, keeping in touch with your fabricators is definitely a must when working with flex, just like you would with a rigid board. You need to communicate with the fabricators you're going to be using for producing your designs to ensure you're using the right materials and following their fabrication processes. Every fabricator is going to be a little different, so you can't just use blanket rules. Generally, you need to work with the fabricator.
Yep.
Let's see here. We have another question about, does the bend area also transfer to NX through ECAD MCAD IDX file? And yes, it does. The IDX file is an intelligent data format. It's an industry standard. It's not anything specific to NX, but NX does understand all the information that's transferring through the file. So things like bend area, the board outline, the stack up information, components, traces, copper. You kind of see this in the webinar, all this information that can be transferred over into the MCAD tool environment for a lot of various reasons, for like doing thermal simulation. And to answer this question, yes, the bend areas do transfer over, so the mechanical engineer can take advantage of that information in bending the flex inside of the MCAD tool as well.
Here's another question. I'm going to ask this one to you, Brent. Did the rigid flex design capabilities that you demonstrated work the same way in Expedition as they do in PAS Professional?
Yes, Expedition PAS Professional is built on Expedition technology. So the flex capability that's part of Professional is a direct transfer over from Expedition. So if you're watching this webinar and you are using Expedition, then everything that I've shown in here is the same technology that you would use in Expedition, and Expedition has some additional capabilities as well.
I have another one for you. I think you demonstrated with NX on the MCAD side, and because you're the collaborator, it was the ProStep IDX collaboration format. Is that, and I think you also mentioned you can read in other files if people don't utilize that IDX format. What were those file types again?
Yes, so Professional, you don't have to rely on just the collaboration interface. If your MCAD tool doesn't create IDX files, you can bring in IDF information, which is kind of the first generation of MCAD collaboration. You can bring in step files of a board outline, and you can bring in DXFs. So Professional has intelligent capability to take the step file and turn it into an intelligent board outline by selecting the surface, and then you can use cut capability or merge capability to turn that one solid shape into multiple shapes used for, say, a rigid flex design where you have multiple areas. The same thing can happen with DXFs. A lot of times when DXFs comes in, they're going to be multiple polygons, and you can merge polygons together with some intelligent capability to create the flex regions that you need. So you're not limited to using the collaboration tool that I showed during the demonstration. It's just the best and most streamlined process for bringing in MCAD data. You can use STEP, IDF, or DXF as well.
Yeah, I think when you use the IDX file, you actually can pick and choose, geometries and things to bring in and out. You have a real-time data exchange that continues to keep ECAD and MCAD designs in sync too. So there's a big advantage for the IDX part, but like you said, it's not a deal breaker to not have a MCAD tool that supports IDX.
Yeah, I mean it's a full collaboration interface, and we did a webinar on it actually back in January. So if you're interested in learning more about collaboration, go to the pads.com website and you can find the MCAD ECAD collaboration webinar. But as John mentioned, it is a full collaboration interface, so it maintains a history of everything that you've transferred back and forth between MCAD, ECAD, which provides a lot of benefits.
Yeah, true. And you can also go to our website and we'll show you all of the MCAD tools that are currently supporting that IDX format. You have anything else, Brett?
Let's see. If there's no bending, can we place ICs like QFPs, BGAs, QFNs on a flex? Yes, you can use a flex circuit as just a circuit board. There's a lot of designs out there today. Example might be like a Fitbit or something like that, where the entire design is being, arced. It's built out of flex, and so you can place anything that you can place on a rigid board. You can put on a flex circuit. You just need to keep in mind in how much it's going to flex, and you might have to use small rigid areas behind where ICs or components are being loaded, so it may not bend quite as much and cause fracture in joints. And you can place all of that, obviously very easily in PAS Professional. So another question here is, do you have standard set of design rules for the tool which closely match manufacturing for fabrication and assembly? So in PAS Professional, no, we don't have a set of design rules specifically for manufacturing, but you can look at bringing Valor in-house, which is the number one tool in the industry for fabrication and assembly verification, which do have design rules for manufacturing and assembly. And you can, if you are tied close enough to your partners in that space, you can ask them for those design rules, and you can import those directly into Valor, so that you don't have to try and replicate or recreate those to do validation.
But to that point, if you were constantly making rigid flex designs and you had a stack up and everything already defined, you could actually save that as a template and reuse that for the next flex design you had, right?
That is correct. In fact, I started the design in the webinar using a template which had stack ups and stuff predefined in it already. So from that perspective, if you are creating multiple flex designs at your company, yes, you can create templates where you've already predefined your stack ups for fabrication assembly. You can also predefine your design rules and import those or have those part as the template, so that you don't have to recreate all that content for every design you create.
Yeah, I mean, that's a good point, because like a company like that, Drill, for example, they may have, different variations of variable speed, set speeds, and the flex just may be a little different configuration, a little different components, not necessarily alternate components, but actually completely different things that may have the same stack up, but they can actually, move quicker through the next design process once they have that template in place.
Yep. So another question here is, what would be the current carrying capability in a flex area? Well, good question, because that's one of the big advantages of using flex materials, is that their temperature range far exceeds rigid board. I mean, as far as calculating the current carrying capability of a copper object on a flex, it's the same thing as how you'd calculate it for rigid. But it can handle a lot more heat. In fact, a lot of heaters that can be used in different products are built on flex material because they can withstand so much more heat. So that was a good question.
Hey, well, I think that's all we have. Thanks, Brent. Appreciate you coming in and on the PCB Tech Talk after the webinar podcast again.
Yeah, thank you, John, for having me. I appreciate everyone that attended our webinar, and if any other questions happen to pop up, feel free to comment on the blog.
Well, thanks again, Brent, and thank you for joining this special After the Webinar Series podcast on Rigid Flex. For more information on this podcast, as well as a link to the on-demand replay of the webinar discussed, be sure to check out the show notes. There, you'll also find additional information related to this podcast along with my email address, so feel free to send me your comments and questions or any topics you'd like to hear me talk about, or if you'd like to be my guest right here on PCB Tech Talk. I'm John McMillan. Thanks for listening, and be sure to subscribe to this podcast on iTunes, Spotify, or your favorite podcast app, and be sure to catch the next episode of PCB Tech Talk.